Hi students, this is Mr. Yao. Today we are going to talk about 6.7, where we will expand our understanding of geometric sequence. First, let's start with some prior knowledge. This is basically a review on what we have learned in the two previous lessons about the recursive and explicit formula for geometric sequence. For the first one, we're writing recursive and explicit formula. No matter which form of formula you're writing, you are going to need two different things. You're going to need an a sub 1, and you're going to need to identify the r. So, for the first example, our a sub 1 is easily identifiable, that is negative 18. In order to find our r, that is negative 36 over negative 18, or negative 72 over negative 36, or negative 144 over negative 72. They will all give you a 2. So we can easily write our second part of the recursive formula, a sub n equals a sub n minus 1 times 2. And the explicit formula is going to be a sub n equals negative 18 times 2 to the n minus 1 power. Something I want to emphasize again, when you write the recursive formula, make sure you include a sub 1, because that is part of the formula. You have to have that and the relationship between a sub n and a sub n minus 1 to use the recursive formula. Now part B, recursive formula, a sub 1 is 72. We can find our r, which is 24 over 72. That simplifies to be 1/3, or you could do 8 over 24, or 8/3 over 8. And the explicit formula, a sub n equals, a sub n equals a sub n minus 1 times 1/3. That is the second part of recursive formula. And explicit formula, a sub n equals 72 times 1/3 to the n minus 1 power. 1/3 needs to be inside parentheses, because n minus 1 is not just on the 1, it's on 1/3 altogether. These are the things we have learned before. Now let's move on to today's example. Example 1. Give a recursive formula, find an explicit formula. The geometric stuff is actually easier than the arithmetic, because when you do this, everything is already given in the formula. You just need to identify them. So a sub 1 is negative 7, that's given, and our r is right here, which is negative 7. So explicit formula, a sub n equals negative 7 times negative 7 to the n minus 1 power. Technically, you should actually combine them, but I'm not going to require that. Example 2, you are given the explicit formula. Let me write the formula again. A sub n equals a sub 1 times r to the n minus 1 power, which means whichever item has the n minus 1 as an exponent, that is going to be your r. In this case, our r is negative 15, and our a sub 1 is 9. So when I write my recursive formula, a sub 1 is 9, and a sub n equals a sub n minus 1 times negative 15. That is example 2. Next, example 3. So again, no matter what kind of formula you are given, you need to identify a sub 1 and r. In this question, we just have the r given, but no a sub 1. We only have a sub 5. Well, here's the thing. R is basically a relationship in every two pairs. So every two terms. So that means based on that relationship, we can use a sub 5 to find a sub 4, then find a sub 3, and then find a sub 2, and lastly find a sub 1. We can trace it all the way back. So a sub 5 is right now negative 1 over 125. Our r is negative 1/5. If you think about it, from a sub 1 get to a sub 2, you'll multiply by negative 1/5, then multiply by negative 1/5, multiply by negative 1/5, multiply by negative 1/5. But this time we are going backwards, so we can't just multiply by negative 1/5 anymore. It's like we are actually dividing by negative 1/5, which is the same as multiply by a negative 5. So that's what we are going to do. Negative 1 over 125 times negative 5. That is going to give us 1 over 25. We're going to do the same times negative 5 again. That is negative 1/5. And we are going to times negative 5 again. That is going to give us 1. Then times negative 1 over 5 again. That is going to be negative 1 over 5. So our explicit formula, a sub n equals negative 1 over 5 times negative 5 2d at minus 1 power. That's example 3. Example 4, same idea. We are going to use the given relationship, which means the R is 3. We're going to use that and start from a sub 6, which is 81, trace all the way back until we actually get to a sub 1. But we can't multiply by 3 anymore because we're dividing by a 3, which is the same as multiply by a 1/3. So a sub 5 is 27, multiply by another 1/3, a sub 4 is 9 times 1/3, a sub 2 is 3 times 1/3, a sub 2 is 1 times 1/3, a sub 1 is 1/3. So explicit formula a sub n equals 1/3 times 3 2d and minus 1 power. I still need to use my original R, which is actually 3. That is example 4. Next, example 5 and 6. We're going to use our calculator to actually do this. So given the recursive formula, which is like that, you're going to find which term is -5/81. In other words, is asking you for the index. What is the index for -5/81? So the method we're going to use, because there's something you haven't learned. You haven't learned something called a logarithm. You haven't learned that. So we can't use that to solve this, which would be the easier way. Instead, we are going to use our calculator. And the calculator way that we're going to do only shows decimals. So first we need to find what is -5/81 in decimals. -5/81 is -0.061728. That's kind of enough. Next, because we are going to kind of do a solving equation way, but just have the answer shown in our calculator, we are going to need to have explicit formula. So let's write the explicit formula first. A sub n equals, my a sub 1 is right there, -15 times 1/3 inside parentheses 2d and minus 1 power. Then you are going to type into your calculator using the y equals button, which is on the top left corner, that you're going to actually type in the whole thing. -15, then times parentheses 1 divided by 3, then 2d and minus 1 power. You're going to put in minus 1 inside parentheses to make sure they are together, because some of your calculators, they don't exactly pop up to the exponent part when you do the little caret thing. So -15 times parentheses 1 divided by 3 with the little caret, parentheses, and n minus 1. For this n, we don't exactly have a button for that, but it is the button that says x, t, theta, n. That is the button we're going to use, which is actually next to the green button on your calculator. So we're actually going to type it as x minus 1 into your calculator. And after that, you are going to press the key second and graph. That is going to show you a table. And as you may notice, x is basically a lot of the index numbers. And you are going to, in your calculator, find where is -0.061728. Well, use your up arrow and down arrow to actually move in your calculator. You are going to be able to find that, and that would give you your answer, n equals 6. That is how we're going to do this. Use our calculator with a table with all the given values to find this. Next, example 6. Same process. Let's find the explicit formula first, and we also need to know what is 1/512 in decimals. That is 0.001953. And a sub n is 8 times 1/2 2d and minus 1 power. So type it into your calculator using the y equals button. That is 8 times 1 divided by 2, little caret, then parentheses x minus 1. So you are going to type in that. Let me actually do that. Then you are going to press the key second, then do graph. So 8 times 1/2. Pop it up, a little caret x minus 1, and then everything else I'm going to. Then press second graph, that will show you the table. Then you are going to find where is 0.001953, and that will give you the answer, and equals 13. Now we're going to do a little bit more practice. It's not on your notes, but it's just 2 questions I made up. Here they are. We're using the same sequence for question 1 and question 2. So you can pause here to try these questions. Now, after you have tried, let's have a look. First, we are going to need to find out what is 2048 over 6561 in decimals. That is going to give you 0.31214. Going. Then you are going to type in your calculator using y equals with this explicit formula. This, if you try to find the r is 18 over 27, which will give you 2/3. So my explicit formula is 27 times 2 over 3, then little caret. So 27 times 2 over 3, little caret, then do x minus 1 in your calculator. And then press second graph. And then you are going to try to find where is 0.31214 in your calculator, and that should give you your n as. Oh, let me see, maybe I did it 2/3. No, that actually is n equal 12. So that is my answer. For part 2, if you haven't noticed, you can actually use the table to keep finding a sub 27. However, yeah, in a lot of questions, you're not going to be asked to do the first part. So we're going to use our explicit formula, which is 27 times 2 over 3, 2d n minus 1 power. To find a sub 27 is 27 times 2/3 2d 27 minus 1 power, which is 27 times 2/3 2d 26 power. And that is going to be, your calculator is going to show you a 7.128, since it says round to 3 decimal places, then e-4, which means the final answer is 7.128 times 10 to the -4 power. That is the final form that we want. Another thing is, if you are in the y equals and you're like, wait, how do I get back to my normal calculator screen? What you are going to do is press second and then press mode, which is next to the button second, because that is going to quit that screen and go back to the original one. Now that is everything for 6.7. Thank you.